Again, welcome to PLC SCADA and DCS lab. So we are going to do the third experiment today. So the third experiment in our list of experiments is material handling system control using forward and reverse action of motor. So we are going to use a servo motor. That motor will be controlled through PLC. So we are going to handle a robotic arm like arrangement in our laboratory. So the material handling system control using forward and reverse action of motor with PLC. The aim of this experiment is to control the material handling system using forward and reverse action of motor with PLC. So this is the aim we have to do. So in this we have following parts. So we have conveyor, stepper motor. So then we have sensors, photoelectric, capacitive and inductive sensors. Then we have an electromagnet and limit switches. So these are the parts available with this material handling system.
So very good morning one and all, and this experiment we will see about material handling system. This demonstration will tell you about the hardware related to this material handling system. The objective of this experiment is to handle the material, that is to pick from one place to another. So for an example, here this is the material that we are going to handle. So the material will be picked from one position, that is a particular position, and will be placed in the storage tank. So the components required to develop this experiment are to identify whether the material has reached its appropriate position. So for that we are using a proximity sensor. When the material is metal, we can use inductive proximity sensor. When the material is non-metal, we need to go for a capacitive sensor. So this proximity sensor will detect the object. Immediately we need to stop our conveyor. Generally the conveyor will bring the material from one source, and when it reaches the appropriate position we should stop our conveyor. This conveyor belt is connected to the stepper motor. The stepper motor will help to run the conveyor. So the material will be traveled through the conveyor to the source point. When it reaches source point, immediately the proximity sensor senses the material. So after sensing, I should pick it from this particular position into the source position. So for that we are using a robotic arm. This arm, which is once again controlled through a stepper motor, so we can run it to the forward direction and also to the reverse direction. So when the robot arm is in forward direction, it has to control at this particular point to pick the material. For that, when it reaches the position, I should stop that robotic arm. Also I should enable the end effector. So this robotic arm, which will be controlled through this limit switch. So when the robot arm reaches this position, immediately the limit reaches, so that will enable this particular switch. So when it enables this end effector, this is electromagnetic switch, which will also be enabled. So when the electromagnetic switch is high, it will attract this particular material. Since we are using a metal, it will attach with this end effector, and that will be carried in the reverse direction to the source position, that is that is the reservoir tank, where it should be dropped. So that we are controlling through the another switch when the limit switch 2 is enabled. So this is the another switch. When I reaches the position, that will goes high, immediately that should interlock my end effector. So here this will interlock the end effector. So this will go low, so that will drop your material to the point where you will need to fix it up. Stop. So in this entire process, you could see there are n number of input and n number of output. The inputs are namely proximity sensor, limit switch 1 and limit switch 2. So these three are going to carry the information to our PLC, that is a controller. Also that controller will send the information to our output units. The output units are namely stepper motor 1, stepper motor 2 and end effector, that is this electromagnetic switch. So all these components are connected to my system. This is material handling system. Since I am connecting with a conveyor, that is with stepper motor, and also robotic arm is also connected to stepper motor, I will have 4 different coils. Q1, Q2, Q3, Q4 are connected to stepper motor. Similarly, the arm movement can also be controlled through those 4 coils, or otherwise you can directly pick one particular input or this point, which will connect with all these coils through the counter. Right, you can create an impulse, you can adjust your frequency. So based on your frequency, the output will goes to individual coils from this particular point itself, so which we are connecting through the potentiometer, where you can adjust the speed of your conveyor by controlling the speed of your stepper motor. Similarly, the same for arm movement as well. So we have 2 limit switches. Those 2 limit switches are directly connected to these 2 ports. So these digital inputs are, we have only one digital input, that is the proximity sensor, which is connected with this blue port. If you are making it into a better way, you can connect more number of digital inputs by making connectivity to this yellow port, which we are not using right now. And also the last one, that is digital output, that is end effector electromagnetic switch, which is being enabled or disabled through this Q1 port. So for all these things, we need to provide a power source, that is 24 volt DC between these 2 ports. Right. So the connectivity, these are all the connectivity which we are going to make it with our PLC. So directly this system will be connected to this PLC. This is a programmable logic controller panel, where we have a PLC Verso Max, a manufacturer from G-Fanuc. So this PLC is having certain number of input and outputs, which you could see from the panel. 13 digital input, right, 2 analog input, 1 digital output, 9 relay output, and also 1 analog output. So these ports are directly connected to the entire panel. Here we are having a relay inputs. So these relay inputs, we can take it as a digital input. We can directly connect with this particular switches by making it as an input, or otherwise we can take the information from the system, that is material handling system. Similarly, these are all the relay outputs, which you can take it to the real-time systems. So this module is all about your analog input and analog output. So we are providing with the source, that is 24 volt DC. So directly the system is connected to 230 volt, which is converted into 24 volt DC module. So to my system, that is the material handling system, I need to provide 24 volt DC as a power source, which can be picked from this particular point. So this point to be connected to my material handling system, these 2 points. Right. Similarly, the inputs are to be connected 1, 2, 3. These 3 input to be connected to my input module, that is digital input relay module. The outputs are also to be connected to my PLC module. So this is an empty file where we need to develop our program. So look at here, these are all the different addressing we need to maintain in our program, right, where the inputs are named I1, I2, I3. Similarly, the outputs are named Q1, Q2, Q3. We know that our conveyor should run at all the time. The conveyor should run at all the time, unless otherwise the proximity sensor is sensed, in the sense the material is reached in the starting point. It has to be picked and placed into the reservoir tank. For that, the robo arm should travel towards forward as well as towards reverse. During this entire cycle, the material should not be moved, right? So that we should name, which we should name it like I should run my conveyor at all the time, that is the Q1 should run at all the time. So let me name it as percentage Q1. Similarly, it should stop only when the proximity sensor is sensed, which means I should put it in interlock, normally closed contact, when the proximity sensor is sensed. Similarly, when the robo arm is in forward direction and robo arm is in reverse direction. So the address are namely, you see the address are namely, the proximity sensor address is I1 and Q2, Q3. Percentage I1, percentage Q2, percentage Q3. Right. So now when the material is sensed, the stepper motor will stop. Immediately what we should do? We should do like, you see, the robo arm should run in forward direction. So when it should run forward direction? When the material is sensed. So your I1 should enable your forward direction Q2. So I1 should enable the forward direction Q2. Also, you see, I1 should enable the forward direction, that is percentage Q2. Right. I should run my I1, that is percentage I1 should run my Q2. So when it should stop? It should stop when I reach the position. When I reach the position, that is the limit switch 2. Starting position limit switch, what is the address? Starting position limit switch is I3. So when I reach I3, I should stop. So that let me make it as, when I reach I3, I should stop, that is interlock, which I would like to mark it as I3. Right. So here you have a constraint. When the robo arm is in forward direction, the electromagnetic switch should not be enabled. So for that, this is an additional constraint we need to add, that is percentage Q4. Percentage Q4. You see here percentage Q4. We no need to enable this in terms of forward direction. We should enable only when it is in reverse direction to carry the material from starting point to ending point. So in that case, I am giving it. This will add value to this rung. So you see, this is maybe this should stop, in the sense this entire condition are together. This condition is a separate one. So these two conditions should be looped. So I should use ceiling between these two to maintain our output, because immediately, since we are using limit switch, when I1 is goes high, I will start running forward. When I pick the material, this will go stop. So by the time it will not run. So that controversy should be disabled. I will show in the demonstration with respect to hardware how it is helpful. Right. So let me put a parallel contact. So these two are to be placed in parallel. So I should have a ceiling with respect to the same output, that is Q2. So this concept I will demonstrate when it comes to hardware. Similarly, when I reach forward direction and when I reach my position, I should start going back by picking the material, which means I am reaching my position. That position is your proximity sensor position. So proximity sensor position, which will be sensed by using your starting point I3. So that is starting point I3. The starting point I3 percentage I3. Also the starting point, I have the material which should also be confirmed, that is percentage I1. When these two are met, I should immediately enable my what? Electromagnetic switch, that is percentage Q4. So this should be high and low. We are using only one electromagnetic switch, so that should be used set as well as reset. This is a set contact which will help you to go high, the reset contact which will reset your coil. So followed by this, I should run once. When I pick, I should run back, in the sense the same contact, that is I3 I4 both should enable my reverse direction, because I am at position and I am also picking my material, which is what it represents. That is I1, I3. Both should enable your reverse direction. The reverse direction address is Q3. So that is percentage Q3. Right. Here once again, how long it should run? It should run until we reach our end position. What is your end position? Your end position is I2, which is connected to limit switch 1, that is I2. In the sense, I should make interlock here, that is I2, percentage I2. Now, as I said earlier, these two are together condition. This is a separate one. So I supposed to make the sealing, since the reverse direction is also going to take place for a while. So I should place a sealing with respect to these two. So that is percentage Q3. So when I reach my end position, that is percentage I2, I should reset my what? Electromagnetic switch. What is your electromagnetic switch? That is percentage Q4. I will reset, percentage Q4, which will reset with respect to what? I2. So that is percentage I2. So I repeat again, the conveyor will run as long as we are not at all receiving any product at the proximity sensor. So until the proximity sensor is sensed or until the robo arm is in stable position, it is not moving either in forward as well as in reverse, the conveyor will keep on run. So the conveyor will stop and will try to pick the material. That is, I should start a robo arm towards forward direction to pick the material when the proximity sensor is sensed. By the time the electromagnetic switch is to be low, so that I am going for an interlock condition. So when I am satisfying these two conditions, I will start moving towards forward, right, towards my material. How long I will be traveling in forward direction? Until I reaches my limit switch, that is I3. So when I3 reaches, in the sense the material is in position and I am at position to pick the material, that is I3 and I1s are sensed together. My robo arm is in position to pick, also the material is available, that is the condition. So immediately I will enable my electromagnetic switch, that is set to Q4. So the same condition will start my robo arm to move in reverse direction. How long it will move? It will move until I reaches position I2. When I reaches I2, I should stop my robo arm. Also, I should reset my electromagnetic switch, which will drop the material in reservoir tank. So let us save this. You see, the program is running somewhere. So let me stop the program first and let us save our program. Both hardware configuration as well as the logic that I would like to store. So this is storing, and at the end you will get the message that the program is stored, that is the store to PLC is completed. So for our own purpose, we can load the program. This we will load only when we do not know what is the logic inside the PLC. We are having the same logic in the PLC. For confirmation, let me load. So you see, this is the logic which we have developed. So now you can run. When you run the program, you see the program is running, right? So let us stop it and we will have our demonstration in real time with respect to the hardware components. Thank you so much. So the entire module is running now. The conveyor will bring the material from source point. When the material reaches our proximity sensor, the robo arm will move towards forward direction and will be forward. So there are constraints we develop in our program. When the robo arm is in forward direction, this electromagnetic switch should not go high. In the sense, it should not be pick any material. Similarly, when there is, let me demonstrate. I will keep my material here and I will enable the proximity sensor to this. See, it will not pick any material. Only when it reaches the position, it will start picking. And in the third run, we developed the program that this should move in trigger as well as the end effector should go high only when the material is available here. The material is not available. That is why it is stable now. Let me keep the material. So when I keep it here, the limit switch is already high, the proximity sensor will go high, so that will enable your end effector as well as your reverse direction. Let me give it. So immediately that's it. So these are all the constraints we have. When it is in forward direction, we are supposed to save our energy, so we are not enabling the end effector. And once again, when the material is not available at the starting position, I should now move forward. I should look for the next material. Right? So unless otherwise the robo arm is not in a stable position, the conveyor will not run. Wait, I repeat, the conveyor will not run. When it places over there, the conveyor will start. Right? So that is what your first run is all about. So with this, we will hand over the system to you guys. We can connect through remote system to our system. So our system is connected to the portal. We can access our system. We can interface the PLC hardware and software. The connections are made by our backend team. You can download your program and you can test it in online. Thank you so much.
So in the third experiment, the document you have to submit is like this. So you are controlling the material handling system with forward and reverse action of motor. So these explanations already we have given, right? So this program is developed, we have shown you. This is the Versa Pro program we have developed for GFunet PLC. The same program you have to develop in Picosoft or Logix Pro, and you have to replace here in this space. So that is the work you have to do for this particular thing, as well as you have to write the inference, as well as the use of each sensor that you need to write in this particular experiment. So this is document work you need to complete in this particular experiment. Okay, thank you.